do problem number 3 very well. Let's say our okay. We would like to accept the challenge. Okay.
Sorry, I want to move to the stage. Thank you. And good evening, honorable jurors and all the distinguished competitors. I'm the reporter Liu Hangwu from TV. And today I'm going to make an introduction of the problem 3, Green on the Rock. So this is my outline today. First, I'm going to make an introduction of the problem statement. And then we'll go to our observation video and also the experimental setup. So you can make sense of how the phenomenon works. And then we'll go to our theory part, so you can make sense of the theory behind this phenomenon. And we'll go to our experimental result and also make a comparison with our experimental result and our theory. So finally, we'll reach our conclusion. So this is my outline today. So this is a problem statement. A washer on a vertical steel rod may start spinning instead of simply sliding down. Study the motion of the washer and investigate what determines the terminal velocity. So we will make an emphasis on analyzing the spinning motion and also study the motion of the washer, which I will separate the motion into 3 kind of motion later, and also investigate what parameters determines the terminal velocity. Okay, so this is our observation video and also the experimental setup. And on the left-hand side, you can see our experimental setup. And the camera is used to record the angular velocity. And the camera 2 here, which is horizontal to the ring on rod, is used to record the linear velocity. Okay, so on the right-hand side is our observation video. And in the video, you can see there are 3 modes, which I separate into. Also, the first mode, you can see the washer is, the angular velocity of the washer is decreasing and become more tilted. And in the rebounding mode, the angular velocity increase by time and finally reach the terminal mode, which the washer reach the terminal velocity. Okay. So there are some definition of my experiment. So M stands for mass of the ring, and R stands for the inner radius, and R2 stands for outer radius, and E stands for thickness, and theta is stands for tilt angle. And theta is the angle between the washer and the horizontal surface. Okay. So this is our experimental result. There are 3 modes, and the first mode is I remain the linear velocity as the same value, and as the experimental result, you can see when it reaches the terminal mode, the linear velocity will remain constant. So we get to analyze the linear velocity, also the angular velocity in the terminal mode to see if it's stable. So this is our experimental result we use for different radius of the washer. And the chart shows that when the washer is reached the terminal velocity, the velocity is constant. So in the terminal velocity, it can show that this state of motion is stable. Okay. So let's go to our theory part. So I will categorize this phenomenon into 3 different motions with the different angular velocity. So this is several definition, and the psi dot is stand for the precession angular velocity, and gamma dot is the rotation angular velocity. Big R is the washer's inner radius, and small r is velocity radius. Okay, so we use Coulomb's law of the drag friction to get this 2 equation here. And C stands for the rolling resistance coefficient. And in the first equation, we use the Newton's second law of the gamma direction to get this equation. And Ft stands for the tangent force, and the Fn stands for the normal force. Okay, so for the second equation, we use Newton's second law of the z direction to get this equation, and z stands for the z direction. So as you can see in this equation, Fn is equal to normal force, which is the same value as the centrifugal force. And also, the dry friction force will depend on the angular velocity. So we will rewrite the two equations here to this term. As you can see, and we solve the equation on the gamma direction to get this differential equation. And in the first mode, the washer wouldn't slip on the rod, so the gamma dot will be bigger than the gamma dot slip. So this is our prediction of the washer's angular velocity. So our threshold is that gamma dot slip is equal to this value, and this part is the function and the motion we predict the washer will tend to motivate. Okay, the function of this part is like this, which we predict. And when the angular velocity is smaller than the gamma dot slip, it will start slipping. So we couldn't predict the function which it will look like. So this is our experimental result. As you can see, the first mode, which is this part, and the start of the first mode, which I mentioned in here, our prediction. Okay, so as you can see, this part of the motion is looked like the inversely proportional decreasing. So it means that our assumption is pretty precise, and C is stand for the rolling resistance coefficient, which I mentioned before, and its benefit theory is this value. Okay. So we'll get to analyze the terminal mode, and there is a definition again. And when the washer reaches the terminal velocity, so gamma is a constant. Okay. So we try to analyze the angular momentum of the washer. So we separate into three axes, which is perpendicular to each other. And for the inertia metrics, there are three components. And axis 1 is geometrical symmetry to axis 2, which is ambiguous to see. This is axis 2, and this is axis 1. So as you can see, it is geometrical symmetry to each other. So I1 is equal to I2 and equal to this value, and also I3. So the angular velocity vector is looked like this, and 1, 2, 3 is stand for the different axes. So we can get the z component of the angular velocity by the previous calculation and also analyzing the angular momentum like this. So we can get the final equation of the terminal mode is analogous to a threefold equation, and we use Newton's second law on the z direction to get this equation. So this alpha g is stand for the z component of the gravitational force, and alpha is the reducing constant, and also this value is the z component of the force caused by the rotation and also the friction. So in this terminal mode, the potential energy will turn into actually three kind of energy. One is the friction, and one is the linear kinetic energy, and also the rotational kinetic energy. And simultaneously, the linear and angular velocity increases. As I mentioned before, the dry friction will increases. It will lead to the linear velocity and the rotational velocity reach the terminal velocity. So this is our theoretical model. So this is the helical path of the contact point. So it is a spiral like this. And our hypothesis is the washer in the terminal mode have no vertical sliding because the terminal angular velocity is bigger than the gamma dot slip. So we can get delta z like this by this chart, and this part of the formula is the slope of the helical path, which is the slope of this. Okay, so we could measure the terminal linear velocity and also calculate the delta z, and finally get to calculate the terminal angular velocity. Okay. So this is our experimental result, which I make a comparison with the experimental result and also the theory. And there is a tiny arrow bar left here, but it's so ambiguous to see. And there are four different radius of the washer, and as you can see, I adjust, and the error value is 5.6%, and the orange point is our experimental result, and the blue point is our theory. So I think this result is much precise enough to fit our theory. So this is our conclusion. We analyzed the origin motions with some characteristic, and we also understand the transition of the sliding and spinning motions, which is the first mode and the rebounding mode, and also the terminal mode. Okay, so we also make a qualitative explanation and also a qualitative model for the steady state. And we all, for example, we calculate the terminal linear velocity and the terminal angular velocity. So this is our references. And that's all my presentation. Thank you for listening.
Can you go back to the page where you show your experimental setup? How far exactly is your camera to your rod?
It's about 2 meters.
Okay, do you think that will affect the result from that you observe the rod?
No?
Okay, how do you measure the speed then?
Just use, I used slow motion for the 240 frame per
Okay,
second.
how do you?
You use tracker to analyze.
Use tracker, okay.
Yeah.
Another point, can you go to page 12?
So, okay.
So you mean that there's only, how many contact points do you think there is?
Just one.
Just one?
Yeah.
Okay. Can you explain again how the rebounding mode, the part of the rebounding part? Can you explain it again?
Because there's an tilted angle, as I just mentioned, in the you can see the theta is become bigger,
Okay.
right? So the potential energy transforms into the angular velocity.
Okay, thank you.
Yeah.
Have you considered the thickness of the washer?
Washer?
The thickness of the washer?
Oh yes, we analyzed the angular momentum. Yes, so in the
Okay, you mentioned
inertia.
in your formula about angular velocity.
Sorry.
Is it in your formula about angular velocity?
We calculate the gamma z right here,
Okay.
and the gamma z, omega z is in this
Can you explain that offline?
Okay. So I should calculate.
What does it represent? Honorable judges and fellow competitors, the opponent from this examination, and I'll be presenting problem number 3. As the problem stated, a washer under a steel rod may start spinning instead of simply sliding down. Study the motion of the washer and investigate what determines the terminal velocity. So the main focus on this problem should be on the motion of the washer and the terminal velocity. And this is our outline. So first, for the reporters only, the theory is that they have different angular velocity, one way into free motion, and they use Coulomb's law of sharp friction and the second law to model the friction force. And they use potential energy turns to linear kinetic energy and rotational energy, so there's no vertical sliding. And the parameters they use are the radius of the calculated radius of washer to and the length. The conclusion is that drive friction force depends on the angular velocity, and the motion first law fits the predictions of the formula. The potential energy turns into linear and rotational energy. They have qualitative explanation and all, but however, the model after the first period, they say that they cannot predict it. So for the pros and cons of the reporter, the pros is that they clearly demonstrate their experiment setup. They use Coulomb's law to analyze the model. They put forward their prediction and compare the results. However, their cons are that they lack of different parameters, like the different radius of the exact radius and the difference between the radius, inward and outward, etc. And they lack a clear explanation for the results, and they lack clear evidence for their conclusion about something like connecting points and stuff. And they have uncomplementarity with the constant. And now there are some points that I want to discuss for the next few minutes. First is about the contact points and the assumptions of the forces, and about the gravitational resistance they mentioned on the TYPT, and about the experiment versus paramount placement of their experiment and how they measure the data, and the proof for their analysis. And other parameters I think they need to consider is actually the vibration of the rod. Now I would like to start the discussion. Yes. So first, why do you assume that there's only one contact?
Because I just investigated that the contacting point actually have two different situations, which is one contact point and second contact point.
Yes, very good.
Yeah. So I have a definition here, which is the here. Inner radius and outer radius, right? So we use the ring for our washer, and ring is a kind of ring is a kind of washer. So what I know is the value of R2 minus R1 is big enough, and the tilting angle theta is big enough.
How big exactly?
Differentiated by R and R2.
Have you measured it before?
Sorry?
Have you measured the data?
Measure data? Data?
Yeah. Because you say that if it's big enough, then the radius.
I use tracker to track the angular velocity. So as I mentioned before, so I apologize that I didn't put the sight from the horizontal direction here, but it actually is a one contact point situation.
How do you prove it? Can you prove it?
No, but I just said I didn't put the.
You didn't put that into consideration, but can you prove that there's only one contact point?
I just said I used video, but I didn't.
Okay, can you go back to the video about your demonstration?
Yeah, that's sorry.
Is it possible that you pause the video midway? A little bit more. Okay. So can you prove it that it's only one contact point from this view?
I just said I have the horizontal direction of the video, but I didn't put on the floor point. So I couldn't prove that it is one contact point, but I can assure that because I have the video, but I didn't put on the floor point. Is that
so what do you observe from above? What do you observe? Can you draw it on the blackboard, please?
Yes, of course.
Since you don't have the video, you
Yeah.
can better visualize it when you draw it.
You mean the tilted?
The camera comes from above.
Yes, just like this is rock, and this is our washer, and outer radius, like this,
Okay.
and this is a contact one,
Yeah.
just like that.
So that's what you observed.
Yeah.
So is it a full circle? Is it a circle?
You mean this?
Yeah. Is it a circle?
You mean theta is equal to 0 or another?
I mean,
value?
from your observation, is it a circle?
Depend on time.
Depending on time. Okay. And terminal. Oh.
Turn more.
Yeah.
It's a oval.
It's an oval.
Yeah.
Okay. About this camera that's filming from above, I think I have a few questions about it since it's actually the camera, the way the camera works is that the light goes into the camera, right? So if you film it from above, there's actually a chance that you're just covering everything from the top. So I have a bit, I think there's a bit of question over here. Okay, we can move on. Can you go to page 17?
17.
Let's continue what we had before.
Oh yeah, you want to know the
alpha? Yeah.
Yeah. Okay. So may I go to the backboard?
Yeah, sure.
Calculate. Okay. So as I mentioned before, I used the unit second law on the z direction to get this.
I mean, what's the meaning of alpha?
Yeah. But
Does it represent?
But I just mentioned before, alpha is a reducing constant.
Okay, what is reducing it?
Okay. I don't here. Okay, so on the z direction, we have the m times r this, and this is equal to the linear acceleration, right?
Yeah.
Yeah. Okay, so it equals to the first is the gravitational force, mg, right?
Yes.
Okay, so the friction is the inverse direction, right?
Which
So-
friction exactly? Is it the dry friction or the rotational resistance that you mentioned?
Just the friction on the direction. What
I mean, what type of friction is it? Is it Is it a static friction? Is
Ah,
it
static friction.
Oh, it's static friction.
Yeah.
Okay.
Okay, so static friction is caused by the m times the because this is the B, right? Yeah. So this is the centrifugal force, right?
Yeah.
Yeah, times the coefficient. And also the angular momentum I analyzed before is times R with omega times m. And this is a constant, and yeah, just like this.
Okay, so you mean that the resistance is only proportional to the, is it only resistance of the friction? The dimension over here, is this only the thing that's affecting alpha?
Alpha, no, alpha is, we rewrite this equation, right?
Yeah.
So basically this is constant and m r squared and also mu, and also these are containing the gamma dot squared, right?
Yeah.
Yeah. So this r and n are also constant, and r and m are also constant. So
So you move it over.
yeah.
I understand. Can we go back to page 18? You can stay here. Can you please help me turn back to page 18? Okay, can you explain me what does x mean?
Oh, XC is the location of the center of the washer.
The center of the washer.
Yeah. It's yeah.
The center of the washer. You mean
Because-
center of mass?
Yes.
Okay.
Of the washer. Okay.
But from my understanding, can you go back to page 12?
Yeah.
Isn't the center of the distance between the center of mass and the washer is this one? Is that
Yes.
the same? Okay, but according to your theory, the distance is equal to the radius of the big R minus the small r.
Yeah.
So I'm going to go back to page 18. Won't that just be 0?
No. This is not equal to this one.
Okay, but what does it mean?
I mean we use the xy axis and we analyze the
I mean, can you give me the definition of XC?
yeah, of course. So I didn't have a definition here, but I have designed it. This is the deduction out to the paper and no deduction.
Deduction.
Yeah, and this is x and this is y, and so the xc mean is here.
What exactly? What is x0, y0 mean?
The location of the center of mass.
The center of mass. And XC should be a distance. So what is the distance between the center of mass to what?
Spirals radius
Spiral swing. What do you mean by the spiral swings?
in the yeah that thing.
Okay, so is the spiral radius y?
That you what do you mean?
I mean, you mean spiral radius?
Because
In your formula, I assume that the way you calculate the distance is by getting the spiral, moving a spiral into like a triangle-like, and this distance should be 2 pi r.
yeah.
Okay, so you mean that is it this 2 pi r the thing that you mean? Is that what you mean?
Yes.
Okay, so why is it not 0?
What
I mean,
would this
I mean, what is the, okay, fine. Can you prove this to me? The slope.
no actually
What?
because this is trivial.
This is trivial. Okay, I understand. Okay, another thing. Can we go back to page 7? Oh no, first go back to the demonstration video. Okay, can you show it again? Okay, so apparently there is actually vibration on the top of the rod when it first releases.
Yes, it just showed that.
I know you didn't calculate, put that into consideration because it could be small, but what do you think that it might affect?
But actually, when I analyzed the data, I didn't use this experimental setup. This experimental setup is let you know how the phenomenon goes. But we use our data to stabilize the.
Okay, I would like to conclude our discussion. First, about theory. I think about the contact points that they actually need to prove it because from the observation video, we actually can't really tell how there is only one contact point or two. We cannot determine that exactly. And they didn't give proof of the video from above, so we cannot actually assure that either. And about the assumption of forces and other formula that they write afterwards, it's all based on the assumptions that there's only one contacting point. So if they cannot prove that, then it might also mean that there could be some wrong things inside of the theory. And for the camera placement, it's just a slight thing, but I think if the camera is actually closer, it will reduce the error. And they don't have really good proof for the analysis, and they didn't mention that the formula is from the reference before. And I think the vibration should be taken into consideration. Thank you.
Hello everyone, I'm today's reviewer, and I have some questions to ask before I comment. Then maybe I ask you first. And you mentioned that the connect point, and what do you think about the water in the water?
Why does it matter?
Why they have two connect points?
Because from our observation, maybe that's not that obvious in the video, but from our observation, we can actually see that when the washer is turning to our own side, the gap between the rod and the rim is different. This can only happen if there's only one contact point. If there's only one
So
contact
in
point.
every situation, it's always the same. Or
No, in the first mode, it should be only one contact point. That's true, but we're talking about the terminal mode, which is the problem is asking.
do you have to correct the radius of the rod and the relationship between the radius of the rod and the radius of the washer? For the connect point, you think it's related to the radius?
Yes, I think it's related to the radius of two.
So you think the hypothesis is correct?
I think we don't really have any proof to prove it right or wrong, but it does, the PowerPoint just shows that we have proof that it's wrong.
For your experiment, I see that the experiment will have a bigger terminal velocity. Your experiment,
Yeah.
can you explain why?
You mean the
In page
8 PowerPoint, sorry.
Can you explain why?
So I actually calculate the velocity by this.
So you think it's all influence of the mass, or it's more influence of the moment of inertia?
Radius? Inertia.
And do you try any parameters for rod?
Rod?
Do you try any
Small?
rod?
Yeah. I already tried, but I didn't put on a slide, sorry.
And I see your rod vibration. And can you
You said?
if the rod doesn't vibration, what will influence the motion of the washer?
It seems that the error value will be smaller.
What about it?
Oh, you mean how will the
Vibration.
vibration affect? I think the vibration actually affects the terminal velocity. Because the vibration, it has its own frequency, and the frequency.
I think there is a couple. Thank you.
Thank you.
previous statement said that a washer on vertical steel run with start spinning instead of simply sliding down. Study the motion of the washer and investigate what determines the terminal velocity. And I think the main focus is the motion of the washer and what determines the terminal velocity. And overview the reporter. And for observation part, he have a experiment set up and the 3 mode and also a video and a definition for the terminal velocity. And the theory is the angular momentum and Newton's second law and Coulomb's law. And for experiment part, he have a first mode and prediction of angular velocity and third mode. And there's no vertical sliding. And the conclusion is when the mass is bigger and the terminal velocity will also be bigger. And the proof is fluent English and the clear diagram and experiment theory very clear. And the cause is forget to explain the diagram and without a clear conclusion. And overview the opponent. And he basically talked about the parameters they do for the conclusion of a reporter, which is a bird motion, fits the formula they list. And for discussion part, they discuss about the kinetic points and a portion of the force and vibration. And of course, it's good conclusion of a reporter and have a fluent English and only focus on the certain points. And didn't talk about the experiment part. And now it's a discussion part. Their first topic is for the parameters, and the reporter's opinion is according to a video, but he didn't point out any formula to prove it. And he explained it with a blackboard and no definition. And when explained, quite not sure. And opponent asked about the connect points and the friction and what the function mean, and also definite of the XC. And for my opinion, and I think that there will only be one connect point through my video, and according to the observation. And we think that opponent can more focus on what experiment he do, and also can point out the parameters that can suggest the reporter to do. And for the next discussion, and they also discuss about the formula. And now and for the missing point, I think reporter only do not too many parameters to say about what determines the terminal velocity. Maybe I suggest him can do a different material of a rod and also the length of the rod. Maybe you have a different conclusion. And he didn't consider about the vibration of the rod. And if the rod didn't have a vibration, and maybe it didn't cause the terminal velocity. And he only considered about the connect point is only one, but another situation is maybe the contact point will have 2 points, and it's related to a radius. And thank you for your attention.
For Jordan on the distinguished competitors, I'm the reporter from TV. And first, I'm going to apologize that I'm misunderstanding the reviewer's question that if I change the material or the radius of rod. And this is our concluding remarks. And question one is how to assure that it's only one contact point. And we use multiple rings to observe. But however, the video is not demonstrated in the report. And the question two is please explain the equation of the direction and as I just showed by Newton's second law. And so question three is XC equal to this value. And XC is the projection of distance to xy plane. Since the washer is tilted, there will be a difference in the equation in this case. So question four, does the vibration of the rod affect the result? Do you choose rod material as parameter? So my answer is the rod is fixed on the both sides, but didn't show on the demonstrated video because we have another experimental setup when analyze the motion, so which prevent it from vibrating. So we did not use different materials of the rod. Sorry for misunderstanding the reviewer's question. So this is our concluding remark, which is our improvement. So to improve our experimental result or even the report, we could show the vertical view of the top setup to prove that just one contact point, which the opponent didn't disagree with me, and also consider the difference between 1 and 2 contact points, and also present clear explanation of the equations, and also provide tracker graph to support the signal mode. Thank you for listening.
Please stand up. Any questions?
A question to the opponent. Could you explain again why there may be more than one contact point?
The reason for that
You
is
can use the
because-
black or you need to draw something.
First, I think there is a significant reason why we need to consider if there's only 1 or 2 contact points. I'll first explain this.
Maybe you can draw a top view.
Okay.
So I can see where are these 2 contact points.
If we're viewing from the top, this is the ring, and we don't consider the outer ring, only the inner ring. And this is the rod. If we observe it from the
So
above,
the rod is not a simple circle. It's
oh no, the rod is a circle. This is a
so
circle.
yeah. Okay, but
Yes.
okay.
Okay, what I
The
mean
washer
is,
is not.
Huh?
The washer is not. a
the
circle.
washer is because when we observe it from the above, it's tilted,
Okay,
so it
tilted.
can
So
be
okay.
an octo-like shape. And if there's 2 contact points, the contact points should be over here. And
If
here.
there are 2 contact points, what do you
Yes.
think the motion will become?
I think the motion will actually be what they observe if there are 2 contact points. The main reason why I kept talking about this is because in their formula they talk about this kind of model, and then they're calculating the distance between these 2 and this 2, and there could be a great difference between these 2 types.
You think the motion they observe is a result from 2 contact points?
Yes.
May I make a
Sure.
So actually, we observed in the video is that the data is not big enough, but also oval, and this is the tilted washer, right? So the rod is here, so it's just one contact point, but I didn't show the PowerPoint. So this is an improvement.
Because for now, because I didn't do the experiment, and for now I cannot imagine how 2 contact points. I think it will. I think the motion will be a little much more weird if there are 2 contact points. But I don't know.
Just like this is ring and this is rod, and like this.
Yeah.
Yeah.
So how do they move if there are 2 contact?
If there are 2
I think
contact
it will be jumpy. I don't know. No.
I don't, from my observation, I think that is because the reason why I assume this is because from what I observed that I think I need to try to make it more correct. When we're looking from the side and we mentioned that this is pointing towards us, this area and this area is different. Actually, it might be possible to see in that video, but I don't think it's possible. So we can
I don't know if there are other questions from the other jury, because times, if there are no more questions, you can continue, but if there are other questions, okay, you can continue.
Just a very simple question. Just now the reporter say you just do the one experiment. You control the diameter of your washer, right?
Yeah.
So you also say you also do the same different experiment. You control the width, control the diameter of the rods. What's the behavior?
No, I just misunderstand the.
Okay, so that's my question. Okay, so if you change the diameter of the rods,
Yeah.
do you expect the diameter of the rods increase and the velocity will become terminal velocity will become up or down?
It depends on the.
Yeah, so explain this one.
Explain. Just
Yeah, just explain. Yeah.
goes in. Okay. For our experimental result and also in our opinion, the bigger the radius of the washer is. Okay. So the small r is bigger and this value is now smaller, right? So in our experimental result, the terminal velocity will become smaller, and also the experimental result. Thank you.
Reporter. 7. Reporter. 7. Reviewer. 7. Okay. 10 minutes break.